Hi, I'm an old guy and I do maths. This is the second in a series on composite functions, and in this video we're looking at whether or not functions can exist or not. In the previous video what we were concerned with was the basic architecture of functions. What is f of g, what is g of f, and how do we put them together and what do they look like? Here we're looking at what happens once you've got the function together and the rules around whether it can exist or not. So let's just run through these. So I think the first thing to say is that there's possibly a new symbol to learn, something from set notation. What this means is a subset of, and in this form is a subset of or equal to. So for f of g to exist, and I prefer this notation, the range of g must be a subset of or equal to the domain of f. Simple rule. If you think about it, it does make sense. We'll come back to it. We'll see this in practice. For g of f to exist, the range of f must be a subset of or equal to the domain of g. Those are the two rules. Now let's take a look at this in practice. Now, what you've got here is two functions which clearly have limits on their domains and ranges. I think that that's pretty obvious. There are a number of these functions. These are not the only ones. Anything where x is a denominator, or x squared is a denominator, or x cubed is a denominator, you're going to have trouble if you try and put 0 into that equation, possibly, or if when you insert a number other than 0, the denominator turns to 0. So 1 over x, if x equals 0, forget about it. 1 over x minus 2, if x equals 2, again, forget about it. That is not going to make any sense. You try that in your calculator, you'll get syntax error or some other unhelpful message. So what we have here, function of x equals e to the x, function of g equals the square root of x minus 2. Our question is, in this case, does f of g exist? In order for that to be the case, the range of g of x has to be a subset of the domain of f. Now, what is the range of g of x? Well, it's in this form, it's all positive numbers. I think it will include 0. What is the domain of f? Well, it's positive numbers. So I don't think that we have a problem here. We apply the test. Is the range of g a subset or equal to the domain of f? Yes. Therefore, f of g exists. Have a look at what it looks like. So f of g looks like this. When fully written out, it looks like this. The domain of g happens to be all positive numbers from 2 to infinity. We'll come back to that in a moment because, as you will see, this causes a problem later, but this is just something to note. For the moment, we can note that this function exists because the range of g is a subset or equal to the domain of f. Now, let's see where the trouble starts. Remember the domain of g. Well, does g of f exist? Well, the range of the function of x is from 0 to positive infinity. And look what we've got. We've got the domain of g. and that is from 2 to positive infinity. So the range of the function of x is actually greater than the domain of g. And that tells us that this function does not exist. That's the simple test. Is one bigger than the other, if you want to put it crudely? Is the left-hand side greater than the right-hand side? There's another way of looking at it. Well, g of f doesn't exist. That's really all for this video. This is just about testing to see whether such functions exist. In the next video, what you will see is how you take a function like this, which does not exist, and, if you will, bring it back to life. Make it exist by placing limits, for instance, on the range of the function of x. How can you do that? Well, simply with the stroke of a pen. However, there then is a question: is it the same function? But that's not a question that needs to be answered here, or indeed in the next video, where I will raise the same question. Simple fact is that this function can be made to exist if we do something about the domains and possibly the ranges here, but certainly this. Okay, well, thank you very much for watching. If you liked this video, please indicate that you liked it. If it was useful and the other videos in this channel are useful, please subscribe, and I will see you next time. Thanks again. Bye-bye.